This is Work and Energy Notes Section 4, and we're on the next problem. This says Joe pushes a 10-kilogram box and it slides across the floor at a constant velocity, 3 meters per second. The coefficient of kinetic friction, so now we know we have friction here, between the box and the floor is 0.5. We're going to add a lot of things that we learned in the last unit. Here is Joe. He's pushing the box. The box is being pushed to the right, is what we'll say, and that would be the applied force that Joe is pushing with. All going in the opposite direction then would have to be the force of friction, and we're going to put a little f with a k to indicate that that is the force of kinetic friction. We know that we're looking at in this direction is the applied force, and we know that the movement or the displacement of the box will also be in the same direction, so our angle here is equal to 0 degrees. Let's use our equation. W is equal to F times the change in distance, which is our displacement, times the cosine of the angle. We'll say that's equal to the applied force that he's using times the change in the distance times the cosine of 0 degrees, which we know that this ends up being the value 1. This is equal to, now our applied force is equal to the friction. The applied force is equal to the friction, so we're going to put mu times mg, and then we'll take that times our change in distance, and remember the cosine of the angle, which is 0, is going to be equal to 1. Finally, we can plug all our values in. They said that the coefficient of friction is 0.5. We know the mass of the box is 10 kilograms, and we know the gravity working on the box should be 10 meters per second squared. We're going to multiply that times that quantity times the 15 meters that he pushes that box. When we multiply everything together, you should end up with 750 joules. So that's how much work Joe does if he pushes the box for 15 meters, and that's positive. They want to know how much work does friction do as the box is being pushed. So because the friction is going in one direction, so here is our kinetic friction, and the displacement is in the other direction, that angle would be 180 degrees. So if we use this same equation, but instead we use that negative value because of the cosine of the angle, you're going to end up with negative 750 joules. On the AP test, you would need to show all the work in order to get there, but for this one you don't. The last problem for this section of work and energy is this next sample problem that you'll see. It says a father pulls his child in a little red wagon with a constant speed. If the father pulls with a force of 16 newtons for 10 meters and the handle of the wagon is inclined at an angle of 60 degrees above the horizontal, how much work does the father do on the wagon? We need to draw this situation, so here's our wagon. We'll put our little wagon wheels on, and here is the handle, and we know that that handle makes a 60-degree angle with the horizontal. So there's our 60 degrees. We're going to say that the work that the father does is equal to F times the change in displacement, or just the displacement, times the cosine of the angle. So here's where the angle really can kind of work in your favor. This is equal to, we know the force is 16 newtons. That's what they told us up here. We know that the change in distance is 10 meters, so we'll put that 10 meters in, and then we've got to take that times the cosine of 60 degrees. If you do your math, you should end up with 80 joules, and that's how much work the father does on the wagon. The wagon then, of course, would do negative 80 joules of work on the father.